All right, everyone. Section 8.4. This is the last section of the first semester. Last section of chapter 8. It's a test of significance for a difference of proportion. So I'm just going to walk you through a generic example first and then a specific example second. Got a little couple mathematical differences, but otherwise it's going to look and feel a lot like the difference for proportions or the confidence or the hypothesis test for a single proportion. So this is called a test of significance for difference proportion. I should say two. So these are conditions. Two independent simple random samples. By the way, they're the exact same conditions as for the confidence interval that we did in section 8.2. So two independent simple random samples, N1, P1 hat, and all of those greater than or equal to 10, not 5, sorry. So N1, P1 hat, N1, Q1 hat, N2, P2 hat, N2, Q2 hat, all just like the confidence greater than or equal to 10. And the population, each population has to be greater than 10 times its sample. This is called a two proportion z-test, so that's the name of it. Okay, so that's how you start. Step number one, right? So we called this one last time, I think. Once you have it, you write your null and your alternate hypothesis. This time, the null hypothesis is always going to be the same. We are testing to see if the two proportions are the same. So we have men, women, over 20, under 20, whatever, United States, Mexico, whatever we're comparing, okay? The null hypothesis is always going to be P1 equals P2. You can write that mathematically if you want as P1 minus P2 equals 0. They mean the same thing. Some people like to do the subtraction because we're going to have to subtract in the problem, and they sometimes make a mistake about which way to subtract, so they like to write it that way. The alternate hypothesis, just like the last one, is one of these three, right? Either P1 is not equal to P2, P1 is greater than P2, or P1 is less than P2. Depends on the context of the problem. We're going to say it. You can also write those mathematically like I just did there by subtracting from each side and putting in a 0. Okay? Doesn't matter which way. Just like before, you compute the test statistic and the p-value. Computing the test statistic is a little bit different, though. Here's how you compute the test statistic. It's going to look a lot like for the confidence interval. You might remember for the confidence interval, it was divided by, I'm just going to do the division part, P1 hat, Q1 hat over N1 plus P2 hat, Q2 hat over N2. The problem is, in the hypothesis test, we're supposed to use our P naughts and Q naughts. Remember, if you go back to the section 8.2 for proportion, in your formula, you're not using the P hats and the Q hats. Hopefully I talked about that in class a little bit. We're using the P naughts and the Q naught, which causes some trouble in this problem because we don't know what P naught and Q naught are for each proportion. We just think they're the same. We don't know what they are. So there's a little mathematical twist. So notice on the top, P1 hat minus P2 hat, that's our test statistic, minus what we expected to get, which is P1 minus P2, which is always 0, because that's what we think to be true. Remember, that's the hypothesis. And then divided by that standard error formula, P hat Q hat over N1 plus P2 hat Q hat, P hat Q hat over N2. Notice there's no 1 or 2 on those P's. This has a little different meaning, okay? So this is new. The P hat, what we have to do is this. We're not guessing. See, really what we should have in our formula is, again, remember, if it matched what we did last chapter, we would do like P1 naught, Q1 naught. But I don't know what these knots are because we don't have a guess for those proportions. We're only guessing the two proportions are equal. So now we're going to guess what they are. So we just have to make a guess, but we're not going to make a random guess. We're going to guess, we have to pick some number that they're the same. So what we're going to do is this is actually called a pooled estimate. What we're going to do is we're going to take my two samples and just dump them in together. Okay, we're just going to dump them together, the two samples, and we're going to figure out what that success rate is. So we're going to take the total number of successes in both the samples, and we're going to divide it by N1 plus N2. And that's going to give me my P hat. When we do the example, you'll see how that works, okay? After that, we find that test statistic. We find a p-value. The p-value, just like last, nothing's going to change in the p-value. Depends on whether it's one-tailed or two-tailed. And then you write a conclusion. The only real big, gigantic difference is in the wording and then this little step right here in finding the test statistic, which we'll do in an example right now. So here we go. We did a simple random sample, and half of the men that we asked lived with one parent. These are like maybe people in their 20s or something, and a third of the women. Okay. And we're going to ask, is there a difference? Is there a difference? Okay. Both of the sample sizes were 150, and we're going to use 1%. We're just going to change the alpha a little bit, use 1%. So my null hypothesis would be P1 equals P2, but you need to say that in words. So the proportion of men, they were between 21 and 24, sorry. The proportion of men between 21 and 24 who live with a parent is the same as the proportion of women. That's always my null hypothesis for these problems, always, always, always equal to. P1 equals P2. My alternate is they're not equal. We might ask, are more men living with their parent than women? If we did that, then we'd have a greater than sign for our alternate. But in this one, we're just going to do not equal to. So I have to do this pooled estimate. So what I did was I took all 300 people that we sampled and put them together. So there's 150 men, 150 women. Okay, I put them together. That's the 300 in the denominator. Half of the men, which was the 75 out of 150, a third of the women, which is the 50. So I got 125 over 300. The pooled estimate is 0.417. That's what I'm going to use for like my guess for what both populations are equal to, 41.7%. So then when I find my test statistic, notice P1 minus P2, okay, 0.5 minus 0.33, minus what we expected to get, which is that 0. And then there you see the P and the Q. It's 0.41. So I don't really like to write it the way the book writes it this way. I like to write it this way, 0.5 minus 0.33 minus 0 over. I like to do this, 0.417, 0.583, because that's my P and my Q over 150. Then we do it again, right? The sample sizes could be different. The book factors it out. Either way is, of course, the same math, but I like to write it like that because that stays consistent with what it looked like for the confidence interval. I hope I have this number written down somewhere. Let's see, do I? Yeah, 2.93. Okay, 2.93. So I should write that here. Sorry, there it was. Look at that, 2.93. All right, so now that's my test statistic, right? Really big, really big. So first thing, I need my Z-stars on my picture. So the Z-stars, remember that we're using a 1% alpha here, 1% alpha. So those are the 2.575 and the negative 2.575. So those need to be on my picture. Always put your critical values on your picture. And then we need to find the p-value. So remember, we go normal CDF from 2.93 to infinity. That's going to tell me that, which is 0.0017, but then I need to double it because of the other side. If it was a one-tailed test, I would not double it. So I get a p-value of a test statistic of 2.93, a p-value of 0.34%. My critical value, or my alpha, was 1%, right? 0.34% is less than 1%. My numbers out here past the 2.575. I'm in the critical region, or I'm in the rejection region. Okay, so I'm going to reject the null hypothesis, which means I'm going to say there is evidence that the proportion of men and women who live with each parent is different. If I didn't reject the null hypothesis, then I would say the proportion of men, there is no evidence that the proportion of men and women who live with each parent is different. Very, very similar to the other tests, and we're going to do other tests for mean and difference of means in chapter 9. The main difference really is just how you find that test statistic. Really, everything boils down to the test statistic in these problems, because the test statistic is how far away are we from what we thought was true. If we're too far away, we reject. P-value comes along with those test statistics also. So that's it for the first semester stuff. We'll go over this in class, clean it all up, do some review, and hopefully be ready for a final exam, and then we'll go from there.